So here we are discussing our hey viewers, we are discussing our topic control unit. Control unit is a part of a CPU which that's the operations of a processor. It performs three main tasks. First one is it fetches the instruction from the memory. Then it decodes those instructions. Then it generates control signals to manage the ALU memory input output device. It basically acts as a system manager, generating specific control signal that directs the flow of a data. They generates control signal, but for the performing of a specific task, but itself do not perform the task. For example, in real world, there is a traffic system where traffic police generate the signals for the vehicles, but do not itself drive the vehicle, just like control unit. Now, let's understand its basic function. The basic functions include first sequencing. So it's ensure that each micro operations are in proper sequence based on the program being executed. And then second function is execution. After sequencing all the micro operations, it executes it sequentially for the proper output. This is done using control signals. Now moves to our next topic is block diagram. Here you can see the block diagram of a control unit. Here there is a first four inputs. The first one is clocks. This key allows to keep the timing signal. What is for the timing signal? Next there is a flag. So flag is these are needed by the control unit to first determine the status of a processor and then for the outcome of the previous ALU operations. Flags can basically are for the status and the conditions code. And now there is a instruction register. The opcode and addressing node of a current instruction in IR. In instruction register there is. It's determine which micro operation are to be performed. And the last input was control signal from the control bus. The control bus portion of a system provide the signals to us control units like interrupts, acknowledgements, etc. And now let's discuss its output. So there are two outputs. First one is from the control signal within the CPU. It calls data movements from one register to another register. Activate specific ALU function like addition, subtraction, multiplication, module, etc. Then there is a control signal to the control bus. Let's control signals to the memory by a control system bus. I hope you guys understand this block diagram. Now let's move to our main topic. Our main topic is hardwire control unit system. Hardwire control unit system. This is our main topic which we are going to study in depth. So before moving forward, I hope you guys understand the control unit. So because without control units you can't understand these topics. So first one, now we are understand hardwire unit control system. It is a part of a control unit system. Now its name is hardwired. It's called hardware because it uses hardware circuits like logic gates, flip-flop, decoder, counters. It doesn't use control memory or macro instructions. It uses hardware circuit. Here we need the proper binding of for the processors. Control logic is this. So I hope you guys understand why it is called hardware control unit system. So now we can know the what are the block diagram. So this is a block diagram of a hardware control unit system. Here we can see instruction registration, instruction decoder, sequence counter, step decoder, encoder, status flag, external inputs. So here the clock first sends signal to the sequence counter. The sequence counter generates timing status like T1, T2, T3. and instruction decoder decodes the instruction. Then the encoder generates final control signal based on a timing and the instruction. So we can understand that control signal depends on timing signal plus instruction decoder output plus status flags. So I hope you guys clearly understand this from starting. So let's further revise it again. What is hardware control unit system? I have described that it is a is a type of controller in which control signals are generated using hardware circuits such as logic gates like AND or not. These are the universal logic gates. Then flip-flop. I hope you already knows flip-flop, decoders, counters, sequential counters, these things. So, and here we have seen the block diagram. First, there is a clock which sends signals to the sequential counter or a control step counter. These sequence counters generate timing status like T1, T2, TX, etc. And then that instruction decoder decodes the information and decoder generates final control signal based on timing and instruction. I hope you guys understand this topic. So now we let's discuss what are the methods of designing control. What are the method of designing hardware control unit system? So the first method is state table method. What is it? State table method. State table method is a systematic way to design hardware control unit. In this method, we represent time states T1, T2. For as you can see in the diagram, T1, T2, T3, dash M, so on M in a rows. Instruction I1, I2, I3 in a column. Control signal inside the table set. So here these are the control signals C111. These are the control signal to be produced in T states of an instruction. So C11 is a control signal at T1 for the instruction I1. C22 is a control signal at T2 for instruction 2. So here let's understand bit for an addition example. So suppose for addition the T1 will be T1 install first instruction, T2 decodes instruction, T3 perform addition and T4 store result. These operations are written in a state table format. In this table we generate the control signals. So I hope you guys understand this. Inside this table where there is C1, we writes the operations in the state table format. So this is the first method and it makes control unit systematic, easy to understand control laws and helpful for designing hardware logic circuit. But it is not very useful if the instruction set is very large. For a larger instruction set, what we use a delay element method. What is called delay element method? This is another method technique to design hardware controls. Let's understand this that in depth. So our the topic is delay element method. It generates timing signal T1, T2, T3 using clock plus delay element, which is not in the state table method. Each delay produces the next state automatically. Here the control signal is equal to timing signal into instruction decoder output. In this method we use delay circuit and the logic gate. It is a fast but a less flexible, but is very useful for the large instruction set. And it is very faster if we compare to the previous one. What is that? State table method. So let's look it in a depth. Let's understand with a proper circuit diagram. Here you can see the diagram of a delay element method. So here the first steps we start. Then in C1 we perform first instruction. Suppose it's store the memory of a. Then third, it's store the memory of a element B. And third one is to store the operation to be performed. For example, if x is equal to 0, then it's perform addition in C4. If not, then it's perform subtraction. In C5, this perform subtraction, and then it's store the result, whether it's the addition or subtraction in C6, then ends. I hope you guys understand this. So, and this is represented in this right side of picture using the logic gates. So here the first in logic there is a C1. C1 for storing element A in a memory. Then we have put a delay circuit. Then C2 for the store of memory B. Again delay circuit. Then we have C3 for the these delay elements generates timing signals. I hope you guys are understanding. Then there is a what we are discussing signal C3. C3 which store the operator, which operator to be perform, and we have discussed it. If it is x, we will perform the x is equal to 0, we will perform what subtract, and if x is not equal to 1, that is it is equal to 0, then we will perform vice versa, what we perform subtraction. So when x is positive, we will performing when x is 0, we will performing addition, and when x is negative and when x is 1, we are performing subtraction, and then we will store the result in our next operator, next element. Suppose A1 is told P1 is told the address memory of A1 of element A. P2 is told the element B, and R is told the result. I hope you guys are understanding this. Now you can see in the diagram, there is a first in the left side there is a flow chart, and it is represented properly in the form of a logic circuits in a right side. Here you can clearly see in the diagram. I hope you guys are understanding this topic. So now our next topic is advantage of a hardware control unit. So first example is it is a very fast operation. You have seen the state table and the delay element, but that these operations perform very fast, and there is no need to fetch micro instruction from the memory, so the execution speed is very high, and then no microprogram memory required. Here it doesn't use microprogram memory. It reduces memory uses and make the system simpler. Then there is a efficient for a small instruction set. We have seen in the state table how it is used for the small instruction set and how much useful it is. So hope you guys understand this. Now these control signals, so they, I hope you understand these advantages. Now what are the disadvantages of a hardware control unit? So first one is difficult to modify since it is a hardware. So here we are properly puts hardware circuits. So for segment we have to rearrange all the elements, all the circuits. This is very time complexity and a complex process. So it is very difficult. So I have to understand it is very difficult to modify as we have to each time ensure proper connection. So and then it is not flexible. The control logic fits. It can't be easily updated like a software. Then complex circuit for the larger instruction set. If our instruction set is large, the system becomes very complex. More logic and the connections are required. तो हमें इसमें और ज़्यादा connections लगेंगे. अगर ज़्यादा perform ज़्यादा बड़ा instruction है, if there is a larger instruction, so there is a larger logic gates. Larger will be the design of a circuit. Larger will be the time. So it's not too good for a large instruction set. We have seen in the state table and a DRAM method. That's it's required the logic gates, which is again I'd say it's a very led to a very complex circuit. And so the last disadvantage is cost increases as the instruction sets grows. As the instruction sets grows, the hardware complexity increases. This increases design and the manufacturing costs, and it is hard to design. Also, hardware control units, if debugging it is also very time consuming. It's a very complex. For a complex matter, it's generally required larger time for the debugging. So we have to ensure the proper and the correctness of a system. I hope you guys understand. Let's quickly remind, recap. First, we have learn control units. How it is a part of a control CPU which direct the operation and it's perform three phases. First one is instruction is fetch instruction from the memory, decode them, and then generates control signal to perform the task to the ALU. Then we have seen its two basic functions. First one is its sequencing. Ensure the each macro operations are in proper sequence. Then it's execute these in proper sequence. Then we have seen the block diagram. Here we have seen there are four input signals. First one is clocks, flag, control signal from the control bus, and then instruction register, which provide the instruction, the macro instruction in the form of opcode. So then we have seen the hardware control unit system. The hardware control units, as I have told you, they use hardware circuit, logic gates, and or not. These are the universal XOR, all these flip flop, D flip flop, T flip flop, all these flip flop encode and decoders and counters. It does not use control memory or a micro instruction. Next, we have discussed the block diagram of the hardware control unit system. It's start from the clock. The clock send the signal, the timing signals to the sequential constant is control step counter, which instructions are decoded by the step decoder, and then these are encoded. So I hope you guys clearly understand this. Now we have seen what are the methods of designing hardware a control unit system. First one we have discussed is the state table method. In the state table method, there is a T states and instruction. There is a T1 state, T2 state, which we have in the studied with the example, and where these T1, T2 are the timing signals and instructions. And the C111 is a means a control signal to be produced in a T state T1 of an instruction I1. Then we have understand what is delay. What is the delay element method? It generates timing signal T1, T2, T using clock plus delay element. Each clock, each delay produce the next state automatically, and it uses delay circuit and a logical, which we have discussed here in this diagram. You can see where we use AND gate and the OR gate. These are the logic gates we use. From the left side there is a flow chart how the instruction goes on, and in the right side there is a proper diagram. Then we discuss what are the advantages of hardware control unit. It is very fast, perform operation very fast, no microprograms memory required, and is very efficient for the smaller set. And what are its and we have discussed that it is very difficult for the large memory instruction. It's required very large memory complex circuit, which is very lengthy, and it is very difficult to modify since hardware requires to same. This is the or we have discussed about the hardware controls. There is another control unit system, micro operation control unit, which is a micro programmed control unit which use control memory and micro instruction. So let's end this video on this session. We discuss in the next topic in the further video. Thank you for the watching. Do like and subscribe the channel.